just 30 more seconds and then we'll get started and the team will take over and present to you guys the progress that they've been making. And don't feel shy. If you have any questions about maybe some of the stuff that they covered in previous webinars on IOx, maybe you want to get caught up, or maybe you want to help to contribute, please feel free to ask your questions, post them in the chat or the Q&A. And if time allows us, then we'll also open up lines. Sometimes it's just easier to chat. And I think we probably can accommodate that. All right, 3 minutes after the hour, you guys are done listening to me. I'm going to hand it over to Marco. Marco, take it away.
If you don't mind, I would just love to do like a brief introduction.
Oh,
as we
of
normally
course.
do. Paul normally introduces these talks and talks about IOx a little bit. I'll try to do he can't be here today, but I'll try to do I don't know, decent impression. We'll see. So just for those of you who might be here for the first time, InfluxDB IOx is sort of a new sort of database that we're building at Influx Data that's designed to handle sort of larger cardinalities and some of the use cases that are evolving. We're pretty excited about it. We're about a year in, and things are picking up steam now that the team's grown bigger and we're coalescing. However, as Paul likes to say, that there's lies, damn lies, and software delivery estimates. And so those of you who've been following along, we've been perhaps more optimistic. Well, we've been visionarily optimistic about how fast the project would go. Right now, reality is setting in. However, I'm feeling good. We're starting to crank through. So today we're going to. Marco is an engineer who's just joined us relatively recently. Is already doing a great job. He's been working on the distributed catalog design for IOx, and I think he's going to present today about what he's been thinking about and what we're working on. So, with that, Marco, hopefully you can take it away.
Cool. Can you see the slides now, and not the code window?
They look good.
Good. All right. Good. Yeah, so catalogs, it's basically the transition from Parquet files that we spray all over the object store and turning them into data sets. So from a agenda perspective, let's first clarify which requirements we at Influx Data have for our catalog. Then what others did as a prior art. You might be familiar with Hive, for example. And then which solution we came up with specifically designed for our use case. So requirements. So IOx is currently able to write Parquet files to a blob store. So on the left side, you can basically see the layout. It's somewhat hierarchical. So at first you have a writer ID, which is specific to the IOx node. Then you have a database. Then everything in the data folder is split or basically partitioned by a partition key. And then you have a chunk ID, and within the chunk, it can have multiple tables, to say so. But now if we just leave it like this and we don't have any catalog, then we have multiple issues. Like one of them is we don't have transactions on the catalog layer, which means that you cannot do certain things like read a Parquet file, do some modifications on it, and write it back in one transaction, basically. So for example, if you want to compactify data or you want to apply soft deletes or whatever, then you don't have any atomic notion, which is bad if you, for example, at any point in time in a distributed system, you might have node failures, and you don't want to have like incomplete transactions on the whole state of your database, at least not on the persistent state. Then if the more your database basically grows, you have increased scan times, basically, because list operations on the object store are kind of expensive, and you have to basically list through all the files to see what's there. And the last but not least thing is that you don't have any schema or statistics lookup. So if you want to plan a query on this whole catalog, you have to look into every single Parquet file at least once at startup to see what's in there. So min-max values, for example, for all the columns. And also how schemas fit together if you want to do any schema unification. So on this catalog, we want to support some operations. Before we go through them, I just want to point out that the operations that we discuss here are specific to the Influx Data IOx use case. So if we are probably coming up with a different catalog design that many others would come up with, and it doesn't mean that yeah, our design is better or worse than anything else. It's just like, if you build a database, you have to evaluate the use case and the operations that you're going to do, and how they relate, and how often you do them, and how performant they have to be. So if you think about the most basic operations that end users will see, we have basically two, right? One is upsert, which is you insert by tag and by timestamp a new value basically into a table, or if it already exists, you want to replace it. And for InfluxDB, this can create a table on demand. So in contrast to a normal SQL database where you would define a table ahead of time, you here have the ability to basically just drop values, and the table gets created for you. And the other one is you want to read the data, obviously, for query it either via SQL or via Flux, for example, as a language. And then you have some lifecycle operations on top of that, things that you don't do that often, but that are still important. The one is soft deletes. I mean, if you want to delete a value, either via a soft delete or later via hard delete, you want to remove it. Then if you think about like crashing nodes, for example, and you have Parquet files that are not part of the whole collection or of the whole catalog anymore, or you want to prune old data and free up some space in the object store, you want to garbage collect basically stale Parquet files. Then time traveling is something that not many databases offer, but it's important for multiple reasons. So one might be if you, for the upsert use case, you can basically replace values, right? And then you might want to go back in time and want to see what was the old state of data, or imagine you have a customer, or we have a customer here at Influx, and they tell us, hey, the query performance here was bad, and then afterwards they deleted all the data or soft deleted all the data, and we want to still reproduce that case. So in that, for that, like a basically copy on write or like time travel semantic would be really helpful. And the last operation is upgrade, because right now, I mean, we are kind of in an early phase of IOx, and there might be future extensions that we cannot foresee right now. So we want to be able to have at least somewhat controlled upgrade of the catalog, right? At least we want to say, okay, at this point in time, we upgrade it to a new format that later on allows us to incorporate new features. And multiple of these operations should form a catalog level transaction. So if you, for example, now have the compactification use case and you want to read a Parquet file, compactify it, or incorporate tombstone records, and you want to write it back, this reading, removing the old file from the catalog and creating the new one should be one transaction that is atomic. You don't want to have any intermediate states there. Then we want to implement this, or we need certain properties from the catalog. So first of all, it should be kind of easy to implement, right? There are really complex designs out there, and we only have obviously limited engineering capacity. And we want to have something that is easy, understandable for us, and we don't want to bother with features that we don't need. Then we want to have, like, we have multiple object stores, right? So we have all large cloud providers, and we have memory for testing and also local file system. And not all of them provide you, for example, primitives like compare and swap, or create a file if it doesn't exist yet, at least not in atomic fashion. Then the catalog should store basically two types of data. So one is the transaction state, is basically which Parquet files are in the catalog. So it acts kind of as a state lookup. And the other one is kind of like an Apache arrow cache, where we want to cache schemas from all Parquet files, so we don't have to scan or like manually inspect all the files. And the other one is the already mentioned statistics. And for avoiding like a single point of failure, we want to be able to recreate this whole catalog from the Parquet file itself. So we want to avoid that the catalog contains information that we cannot find in the Parquet files. So sure, if there's a kind of like a limitation to it, right? If you have not a non-garbage collected data set, this rebuild from files will be kind of like hand wavy incomplete. But it's still you don't have like a full data loss if the catalog is corrupted, right? So we want to have like at least like a soft failure mode here. Then specific to IOx or to InfluxDB here is a writer federation, right? So you have data producers, for example, your IoT device cloud or your server farm, and these produce data, and this is either directly or indirectly routed to one or like multiple IOx nodes. And every IOx node has a unique server ID and will write to either a specific store or at least a specific partition within the store, right? So what you've seen for the naming of the Parquet files is that the very first part of that is the server writer ID. And then either the server itself can read it, or there might be other readers acting on these Parquet files. So that said, we already have at least some separation of the catalogs and of the Parquet files, so we don't need to deal with multi-writer concurrency here as much as other catalogs designs need to do that. Now let's look at some prior art. Right? So most people in this field might be familiar with Hive. And Apache Hive has multiple ways of storing data, but it allows you to use Parquet files as one of the data models. So there on the left side, we have a bit of an illustration. So every table is stored in its own path. So we could use it as a directory, for example. Then you have a hierarchical partitioning scheme. And then within this partition, you have one or multiple Parquet files. On top of that, for every table, you have a file which is called common metadata, and which is basically a quote unquote empty Parquet file. So empty, I mean, it has all the columns but 0 rows. It allows you to do basically one file metadata or like schema lookup. It doesn't allow you to look up like statistics, but it at least allows you to check if your, for example, if your SQL query is saying if it interacts with all the types incorrectly, etc. But it has also several drawbacks. So because a file existence already means it is part of the data set, you don't have any atomic transaction on top of it, at least not for most of the object stores out there. You don't have time travel. You still need to list this whole thing if you want to do a scan in the beginning. Soft deletes don't work. You basically, there's no notion what you should do if you have multiple writers, which we don't need, but it's important to point out. Then it's kind of an evolution originated from Netflix, is Apache Iceberg. Apache Iceberg incorporates many learnings that came with these Hive partition data sets. And so the Parquet partitioning is kind of similar, right? So you have a folder or a directory where you have the actual data in, or like a table in. Then you have a partitioning, and then you have one or multiple Parquet files. But on top of that, you have basically a state-based pointer hierarchy. So a manifest file is the first hierarchy, which is basically a list of all the Parquet files with some statistics and some metadata. Then one or multiple manifests are listed in a manifest list file. And this file is then referenced by a snapshot. So you have a linear list of snapshots. There should be a 2, by the way, and a 3. And you can basically model also deletions, repartitioning, etc. With this technology. The tricky part is basically how do you do snapshot, basically conflict management if you have multiple writers. Also this whole schema, where like this whole model, how this works and how these manifests are built is kind of complex. It's currently heavily, I would say, work in progress, and up until now we only have like a Java and a Python, at least somewhat complete Python implementation. And it is more focused on a single table or a single data set and multiple concurrent writers. So it might be a future candidate for us, but currently it is not what we really want. So it is for the complexity it has, it doesn't offer us a good scaling over multiple tables. Then the next one would be Delta Lake. Delta Lake is a bit different compared to Iceberg. So while Iceberg is saying what a state at certain snapshots is, or certain basically transactions, Delta Lake records the change. So instead of saying a file is there, it says a file was added or a file was removed. It does that by per transaction creating a JSON, which then basically contains a list of changes that were made. And on top of that, because if you have a really, really long list of transactions, then you have to basically play back all of them, which can be really costly. It can have optional checkpoints. And a checkpoint is basically that the state again at this point in time. So it basically says all the files that are part of this, basically of this data set for a certain transaction. Similar to Iceberg, it is also more focused on a single data set and multiple concurrent writers. And up until recently, we didn't have a non-Java implementation or not JVM implementation. There is now a Rust implementation, which is, I would say, kind of far, but there are important features missing. And yeah, it is also more, it is kind of like a misfit in terms of which properties we want. So now that we've explored all the solutions that are out there and the prior art, basically, let me tell you what we came up with and what our design for a catalog is. So similar to Delta Lake, we also will use a transaction-based approach, or basically like a change, right? So we record what was changed during a transaction. So we use like slightly different notion, but it has a transaction file, and we also have checkpoints, which is similar to what Delta Lake offers. For these transaction files, so what do we put in there, right? So we, or maybe before we go into that, one difference here is that our transactions spawn multiple tables, right? So we are not limited to one catalog per table, but we basically can add tables on the fly to the catalog. So we don't need to, it kind of for loads of tables that you can expect in certain monitoring and IoT use cases or tracing use cases, we don't blow up the number of catalogs that we basically expect here. So within a transaction, we have multiple possible actions that can occur, and multiple of them can occur in basically one transaction, and they make up then like basically a higher level construct. So we can add a Parquet file where we store the path of the file, a checksum for later, like basically like file system checking, and Parquet metadata, and I will come to that in on the next slide. Then we can remove a file. Then we can record tombstone records. How they are exactly designed, we will more flesh out in the future, but it's likely that we just store a Parquet file with the tags and the timestamps that we want to delete. And there's a special upgrade message that allows us to have a controlled upgrade path to a new catalog format. So the entire thing is serialized via protocol buffers. And the reason we use protocol buffers here is because we have it basically in our stack and other places as well. We serialize configuration files using it. We have a good amount of gRPC calls. So we don't need to introduce yet another serialization format, and it kind of fits in our stack nicely. And then we similarly have transactions, which is checkpoints, which is basically an aggregate over multiple transactions. And then instead of recording the change, we record the state. And this is basically similar to also what Delta Lake is doing. Then regarding Parquet statistics and schema, so how do we do that? So on the left, or like this picture on the left side, is basically straight out of the format specification for Parquet. And if you're not familiar with the format, it's basically like this. So you start with some magic bits, and then you have all the payload, which is basically like work groups. And at the end, you have a metadata footer. So the footer has some key value metadata, but also contains the schema for all the columns, as well as either directly in the footer or as a link to one of the work groups. It contains the statistics. And because we don't want to re-enrent this whole statistics and schema handling. And we also already know that through the arrow stack, we have a deserialization and serialization layer. We basically want to reuse whatever Parquet offers us. So what we also use the same Apache Thrift serialization format, serialize that to bytes and embed this in the protocol buffers. And this basically gives us the same expressiveness as Parquet, so we can use not only min-max values, but also in the future Bloom filters, for example, or whatever Parquet is basically offering us. It offers us a really easy way to rebuild the catalog from Parquet files because we just need to extract this bit of information. And also we avoid kind of tricky format conversions. So one thing that you have to think about is if you, for example, convert, if your min-max, for example, is a floating point and you want to serialize that one to JSON, you have to be really careful if you go to text and back that you don't mess that up. The same sometimes goes for certain kinds of strings or for numbers that you have to write bit with, etc. And here we kind of avoid this pitfall by using basically the same serialization format. Okay, so I already said that we basically have writer federation, right? And we don't, basically every writer shall have its own catalog. And Conductor, which is our orchestration layer, provides us a cluster write unique ID. And we don't yet, or at least in the near future, will have a inter-writer or like global catalog. So if you want to scan through, if you want to know the global state of over all writers, so either you ask the orchestration layer or you have to scan like a prefix scan through the blob store or through the object store, which gives you like a lookup there. Nevertheless, we want to be as robust as possible, and we don't want to fail because a single point in this whole stack fails, right? So what we do on top of that is that we at least want to detect if the assumptions here are invalidated. So what we do is per transaction, the naming of the transaction file we write is not only like this linear counter starting at 0, but it also contains a UUID specific to this transaction. So if now two writers, which shouldn't exist in parallel, still write into the same catalog at the same time, at the same transaction, you get two files. And we can detect this fork, how we would call it, and at least inform the operator about that the invariance in the cluster wasn't met, which then will probably lead to some manual intervention in a bug report, but at least we have a controlled way of failing here, which is important if you want to have a robust database solution. All right, so this is basically all I had to say about this one. If you want to find out more, so here are some of the links of the prior art, but the last link also contains, or if you also go to the IOx repository and in docs, we have a catalog persistence design document, which does different design options, or which illustrates different design options in a bit more detail. So you have also like simpler designs or like more complex designs, and we kind of evaluated them and thought about what do we need, what is possible. So if you're interested in that, it's also kind of like a good way of getting into how to design things, because you basically want to evaluate complexity versus what is your need versus what extension points do you want to have in the future, etc. So this is might be an interesting read for some of you. And that's basically it from my side. Do we have questions?
Let's see. I don't see any questions just yet, but if you do have a question, please feel free to post them in the chat or the Q&A. Alternatively, if you raise your hand, I can also unmute lines and we can have a chat if anybody's interested. Everybody's shy today, Marco, or you just overwhelmed them with all kinds of goodness.
That's okay as well.
So what's next on the, on the list for you guys? What's some of the bigger things that you guys are really looking forward to?
I hand this over to Andrew.
Oh, yeah, well, okay, we should also answer that for the catalog, but I think broadly speaking, maybe a brief summary of like where the project is might be helpful to answer sort of what the next major thing is. Sorry, I live right next to a fire station. So the next major focus is we have IOx working well enough to put it in an internal part of our sorry, we have IOx working sufficiently feature rich enough that we can install it in our own cloud environment. We're running sort of actual data through it. And I think while we're doing that, it's been a phenomenally valuable exercise. And we've identified a bunch of sort of various things that we're going to next focus on. Right. So one of the major pieces is compression. I think we've got a very good start with the read buffer, which I gave a talk about a few months ago. However, we've identified some other very important data cases to get compression on, and I think we're going to see some massive improvements there. We're also, as we've been designing sort of the federation system that Marco was talking about with multiple writers, I think we need to actually work out how queries are going to work in that distributed mechanism. That's another big piece. And I think also what's been something else that's sort of major that we're probably going to talk about in a little bit is actually querying across data that's actually been persistent to Parquet as well. Right? We're talking largely about in-memory databases, but making sure it goes. So I think, between Marco and I see Yana, who's on the call, they've been actively sort of working on the persistent story, part of which is the catalog, part of which is also the like the actual ability to write Parquet files, read them back, and then query against them.
So there's actually a question in particular about the Parquet files. Narayan asked if the Parquet files are transferable, particularly between Hadoop and Influx.
Yeah, I can take that one. So yes, there should be. So the file itself, we plan that you can probably import them somehow in the future. So there's currently no technical way to do that, but the Parquet file itself doesn't contain any additional information at the moment. We might use some additional metadata. We are not too sure that, but if you write more metadata in Hadoop, you can definitely import them. I think for the interop between Hadoop and or like also any other Presto that either reads a Hive dataset or that, for example, reads Iceberg or whatever. Our take is more that since in blob, right? So in object store, the layout is already be different. So you don't have the catalog, since the catalog looks different, and also where files are stored is different. So there's not much of a point in like reading and writing or like exchanging single Parquet files, right? So even though we might only use a bit of more metadata, why would you like import a single file? There might be still use cases, but in general, what we rather think is that if you want to exchange data with a different solution, you would do like an export, right? So the export will write a new catalog that another solution can read or write to, and it will probably also, I think it will probably just copy over the Parquet file. So we probably don't need more in there, but we currently don't have any interopt, right? So, or like interopt testing. So I've known from some previous projects that like this interopt, like for single or for simple data types, it looks quite easy. But if you really want to ensure that, and you want to offer, or if you would like to offer that as a feature, that definitely needs testing, right? So we would like to have then an integration, end-to-end integration test if this is working, because, for example, if you specifically for Hadoop, right? So the Hadoop's stack is written in Java, which is basically a completely different path of reading and writing Parquet, right? So you have a completely different implementation, which is especially tricky for some of the data types. So one data type that we, for example, support in Influx data or InfluxDB is unsigned integers, right? And unsigned 64-bit integers in Java is a bit of a tricky case. So I don't say it's impossible, but you have to figure out how these different solutions work, and if all the data types cleanly convert back and forth, or at least document the edge cases, right? That can happen.
I think one of the major reasons to have gone with the, like sort of Paul, when he originally set out the goals, sort of the vision for IOx, one of the reasons to choose Apache, the Apache Arrow project and the Parquet file format was the promise of interoperability with the larger ecosystem, right? So I think Marco's being a good engineer and explaining all sort of the stuff we have yet to do to really make that dream a reality. But I think the goal is very much you just take the Parquet files that IOx can create, and we don't have to rewrite the data into some other format in order to share them with some other system, right? The exact details of how we transfer metadata and tell the other systems exactly where to find stuff in an object store, we absolutely haven't worked that out yet. But I think the high level assumption is that by using Parquet, we basically get interoperability with the rest of that ecosystem, you know, and that's one of the major benefits of using Parquet.
Yeah, maybe also to answer the initial question of like, what is the state of the catalog, right? So we currently have at least the read and write path nearly ready implemented. One thing that needs more time than and for implementation, obviously all these like lifecycle things like creating checkpoints, implementing a check, basically like a file system check that walks through the catalog and sees if all the checksums are correct, etc. Implementing catalog rebuilding if the catalog is gone, and then basically on top see how good the catalog scales, and if we have any scalability issues, if we need to optimize one or the other serialization route, and that's basically how we will move on from here.
Narayana, hopefully that answered the question. It seemed like it was very thorough, so thank you so much, Marco. If there's any other questions, please feel free to post them in the chat or the Q&A. And the team would be happy. And looks like Paul's even joined. So if anybody has any questions, if you're new to IOx, new to InfluxDB, longtime user, if you started looking at the code, had some questions, please feel free to chime in. Everyone would love to be able to chat and get your feedback. So Marco, the team has really expanded. I mean, how many people are here today? How many people are on the IOx team? Are you, and then Andrew and Paul, are you guys looking to expand the team further?
I think there's on the order of 10 engineers, and I'm gonna let Paul answer the rest of that question.
10, that's cool.
Well, I think it's 9 people because I don't believe you can count me. I may maybe subtract a few on that list. It's net less. Yeah, so we're at this point, you know, obviously we scaled the team really quickly over the last 4 or 5 months. So we're trying to get our process solidified, a bit more of a workflow going, and also like we're gonna try and like figure out how best we can work with the community as we get things better defined. We'd really like to get to a stage in not too long where, you know, we have design documents and issues and stuff like that going out into the GitHub repo where people can actively contribute, and ideally like we'll start having issues that are flagged that are basically things that other people can tackle. And actually where that is happening for this project is in IOx, but also in the Arrow Rust repo, which is an interesting development that just happened recently, which is Apache Arrow was basically like this. It's this mono repo in GitHub where every language implementation is in the same place. Data Fusion was in there, and this other project called Ballista was going to go in there, or did go in there briefly. The Rust parts got pulled out into a separate repo so that the Rust part of Arrow could be iterated on and actually released on a much more frequent cadence than before. And Andrew's been spearheading a lot of that effort. And I believe he's, do you want to speak about the release cadence and some of that stuff?
Sure. So just to remind everyone, sort of Paul's original vision of IOx was like, you know, to make a bet on this Apache Arrow project, which has the Arrow itself, and then part of the Rust implementation. Arrow is sort of a column and array representation, and it also has various like low-level compute kernels and an IPC layer. We have a whole tech talk about. Then on top of that, there's a thing called Data Fusion, which is part of the Apache Arrow project, but it's Rust specific, and there's equivalents, but they're different systems in other implementations. It's effectively like a base query language. So it's where IOX's SQL implementation comes from, and where some of a bunch of the query operations are coming from. And so trying to align releases like across, I think there's like 10 different implementations of Arrow, some of which are at very different stages of their maturity, right? Like the C++ and all the various libraries that are languages that wrap the C++ implementation are fairly mature. Rust is somewhere in the middle, and then there's like things like the MATLAB implementation or something that are really, and I think the Julia one are very sort of early in their life cycle. And so right now they're kind of all released every 3 months without really taking into account what the individual implementations have been doing. So I think what we're trying to do as an experiment is to pull the Rust implementation out and be able to release versions to crates.io, which is the Rust's ecosystem's software distribution mechanism. Every 2 weeks, I think, is the current proposal, and there's like a final vote on doing that. And I think what that will then allow is more people to actually use the Rust implementation of Arrow. There's a bunch of technical, like, because it basically changes so much and there's only releases every 3 months, I think it's challenging for people who want to be on the cutting edge to actually use what's published to crates. So I think my hope is once we get that sort of more regularly going, we'll be able to attract that many more sort of contributors to the Arrow ecosystem to help with the Rust implementation. And it's already, there's already some great stuff going on there, and I think it's only going to get better as we get sort of a little more agile and aligned processes with more of what's expected from the Rust community.
So how would you like our community to help out? And this is a question to all of our IOX team members. Are there areas in particular that you want them to look at? Do you want them to try something? Do you want them to just hang out? What do you guys want? Because obviously our community is interested in what you're doing. That's why they're here every month. How would you like them to help?
Well, I think the best thing they can do is like look at the repos, right? Well, one is the Arrow and one is the Data Fusion repo. There are loads of tickets filed there. Either might it be bugs or might it be features. Get yourself familiar with it now, especially since like both the code bases are pulled out of the main Arrow repo. I think it's really easy to get going, right? You just like run the test locally and everything just works, and you can easily experiment and like add new features. And I think especially Data Fusion might be really interesting for people to play around with, because there you not only have like the IO layer, right? Because you have the whole query thing that makes it a bit more interactive and a bit more, I think end user usable for many people. And there adding features is really easy. I mean, depending on the feature, but it's something that people can work on without like interfering too much with others. And I think Andrew is also like mentoring a bit the pull requests that are there. So if you need any help, if you're not sure how to implement stuff, just reach out. Or
I think it's got an excellent community, and we're trying to make it more accessible, right? So rather than just some vague giant sort of descriptions of features or whatever, I think we've been trying to like define little individual work items, and you get familiar with the code. If you're interested in database internals, as Marco says, like that's a great place to start, because it's effectively going to directly feed into IOX. And I think my hope is over the next couple of months, at least, when we start doing IOX builds for real, right, then people can play with IOX from the other end and help explore sort of the space we've gotten and help us figure out what needs to be done there too.
Cool. I'm sure the community is really looking forward to being able to play around. Paul, did you have something else to add to that?
Oh, I was just going to say, I mean, yeah, because we're early on, we're not actually producing builds yet and no documentation. It's hard to get involved as a user, but if you're interested in the project, I think one of the best places to be if you have questions is the IOX Slack channel that we have in our community Slack. There's a specific channel for IOX, and we pay attention to it. And there's really not much traffic in there. So if you say something, it's likely one of us on the core IOX team that's going to talk about it. And sometimes we have an answer if it's something that we already have in mind and that's defined. And sometimes it's results in a design discussion or whatever. And I guess the other thing would be tell your friends and your family how awesome this project is. No, not yet, but but we're getting there.
Well, I mean, I think it's really admirable of the entire team to share your efforts so early on, and you know, on a monthly basis, also, you know, come to this forum and describe the work that you guys are doing, and also, you know, sharing the points where maybe there is some uncertainty. I feel that this kind of transparency is really great, and of course, it's super important to open source. So thank you so much to you and the entire team.
I should mention one more thing I forgot.
Please do.
I'm sure you already said that Influx Days is next week. Influx Days EMEA. So if you're in North America or South America, it's gonna be very early. But anyway, there will be a bunch of talks about InfluxDB generally, but my talk is actually going to be focused more on IOx, and I am going to try to show some of the things that are there currently and work, and some of the things that are on the near-term horizon. So
excellent. That's a great commercial for Influx Days. I love it. What we'll also do for everybody that's signed up for these community office hours for the past couple of months, once we have the recording ready from, of course, this session, we'll definitely send it to everybody, but also for the Influx Days session, we'll also ensure to share that link with you so you don't have to get up early. We'll just make Paul get up early to do those talks for us. And
that's
hopefully
right.
next year you could fly and you could just be jet lagged instead. All right, cool. Well, thank you everyone for joining us. We'll be back again in 1 month's time, but we'd love to see you at Influx Days. Love to see you in the Slack channel. We'll also make sure in the email that we send that we share that the Slack channel link with everybody. And any feedback, I'm sure the team would really appreciate it. Cool, cool. Thank you, everyone. And we'll see you again very soon.